Hi and welcome to my channel, me Gummy Lizard. As you may guess, because of my past videos, I'm a huge Star Wars fan. And because of that, I have to have Star Wars props. And one of these props is the Thermal Detonator Leia is using as an undercover bounty hunter at Jabba's palace. This little device looks cool and it's nice to have. So I downloaded the print files and gave my Prusa MK4 a little bit of work. And I made this. But before we come to that, we have a little bit of work to do. And yeah, orange is a cool color, but not suitable for a thermal detonator. And after getting rid of all supports and cleaning up a little bit, I have to prime the surface to make it paint ready. Let's start with the power source. I use a 9-volt USB chargeable block as power source. A step-down module takes the 9-volt and brings it down to 5-volt to the needs of the Arduino Nano. To cut the power, I will set up a switch between the 9-volt block and the step-down module because I do not want that the 9-volt block gets drained while the detonator is inactive. And while developing, I use another switch so that I don't have to press the button the whole time. The power goes to the Arduino Nano, and then there are only the LEDs left. There are no resistors on my table here because these are pre-installed on the LEDs. And what I almost forgot is the buzzer. The buzzer is for creating the sounds if you activate the detonator. So before we can assemble the thermal detonator, I have to create the electronic for that. And I want to use an Arduino Nano for that, and as power source a 9-volt block battery. And because I use that because these batteries are able to charge by USB. They have an internal charger, and I can just load them or load them up with energy by using USB cable. So that's very handy, and I use that. And I have a step-down module to step down in voltage from 9-volt to 5-volt for the Arduino. So we are good on this side. So we have power source, and the Arduino is controlling the 4 LEDs. If we pull the switch on the top of the detonator, the first LED on top will go on and will light up. And this is this here. And then in the same time, a sequence is starting with these 3 lights, these 3 LED lights in the front of the detonator. And while this sequence is running, this buzzer here over here will create a sound like a charging flashlight, which you use in the photography way back in time. They have this specific sound. Everyone who is a little bit older knows what I'm talking about. And yeah, and some of us have really bad experience with a hot flashlight. Let's say it like that. Yeah, and this is the internal electronic. I don't use a PCB, a made PCB. I just using a developer board to solder on the whole components and bring it into the detonator. And the next step is to create this in real life and trying to that the code I have written is working. So let's go to the next step. Now it's time to assemble everything on the breadboard and finally test the code I've written. This is always the moment where theory meets reality. All the planning, wiring diagrams and programming now have to work together in the real world. What I'm most concerned about is now the sound sequence of the device. Timing between LEDs and buzzer needs to feel right, otherwise the whole effect will be off. So before installing everything final, I want to make sure the electronics behaves exactly like it's intended. Before I can plug the LEDs onto the breadboard, I first need to prepare the wires. The wires of the LEDs are a bit too thin and flexible to make a reliable contact in the breadboard, so I start by removing a small section of the isolation. After that, I apply a tiny amount of solder to the exposed wires. This process is called thinning, and it helps to stiffen the wire so it can be inserted much more easily. It also improves the electrical contact and prevents the strand from fraying. It's a small step, but it makes working the breadboard much cleaner and more reliable. Now it's time to set up the breadboard according to the pin layout defined in the code. The red LED is connected to the digital pin D2, while the three white LEDs are connected to the D3, D4 and D5. For the sound output, the buzzer is connected to pin D9, which allows the Arduino to generate the rising tone sequence. I also add a few 5-volt connections, one, so I can quickly test parts of the circuit independently if needed. Once everything is wired up, we can power the board and see if the LEDs and the sound sequence behaved exactly like the code intended. If everything works here, we are ready for the next step, integrating it to the final build, to the final PCB board. Now it's time to assemble everything on the breadboard and finally test the code I've written. This is always the moment where theory meets reality. All the planning, wiring diagrams and programming now have to work together in the real world. What I'm most concerned about is now the sound sequence of the device. Timing between LEDs and buzzer needs to feel right, otherwise the whole effect will be off. So before installing everything final, I want to make sure the electronics behaves exactly like it's intended. The code itself, it's fairly straightforward and doesn't use any complex functions. It simply controls the LEDs and the buzzer according to the timing I want for the device. If you are interested in building one yourself, I'll provide in the next days, I hope so, the complete code and the part list on my Patreon page, so you can easily recreate the project. After adjusting the sound sequence multiple times, I finally arrived at a version that feels right. Getting the tone and timing correct took a bit of trial and error, but I think this version works completely well. Let's power it up and see how it sounds, and hopefully it doesn't hurt your ears. Now that everything is soldered onto the PCB, it's time for another test. Before installing the electronics to the final prop, I want to make sure the detonator sequence still works exactly like I did on the breadboard. So let's power it up one more time and run the full sequence. The space inside the prop is quite limited. Because of that, the board needs to be trimmed down slightly so it fits properly into the housing. After shortening the PCB, the board now has the correct size and fits much better for the final installation. With that done, the electronics are ready for the next step of the build. With the electronics finished, it's time to move on to the paint. For the first coat, I'm using gunmetal paint. This will serve as the metallic base layer for the whole prop. The goal here isn't full coverage in one pass. Instead, I apply several light and even coats, which helps to keep the surface smooth and prevents the paint from pooling in the small details. This base layer will later simulate the exposed metal underneath the outer finish, which becomes important once we start adding weathering and wear effects. Once the gunmetal base coat has fully dried, I apply a chromatic paint from Green Stuff World. This paint creates a subtle color shifting effects depending on the angle of the light. It adds slightly futuristic look while still allowing the metal base layer to shine a little bit through. Again, the key here is applying thin layers, building up the effect gradually instead of covering everything at once. The result is a finish that has a bit more depth and visual interest than a simple flat color. With the paint finished and fully dried, it's time to move on to the final assembly of the detonator. At this stage, all the individual parts are finally come together. The electronics are prepared, the housing is painted, and now everything needs to be installed carefully so that the device not only works but looks clean and convincing as a prop. The first component I install is the activation switch. This switch will later control the entry sequence of the detonator. Control is a little bit over the top, it's just shutting it down or turning it on. So it's important that it sits firmly in place and cannot move around inside the housing. After positioning it in the opening, I secure it with a small amount of glue. This keeps it stable while still making sure the switch can be operated smoothly from the outside with the sliding component of the detonator. Next comes up the top LED, which is one of the most visible elements of the device. The LED will later sit underneath a transparent cap, which helps to diffuse the light slightly and gives the detonator its recognizable glowing indicator on the top. The cap also protects the LED and spreads the light more evenly, creating a softer glow instead of a harsh point of light. Once the LED is positioned correctly, the transparent cup covered carefully, placed on top and secured with a little bit of glue. After that, I move to the front LEDs. These LEDs are responsible for the visual sequence during the activation process, so their positioning needs to be aligned properly with the front of the detonator. Each LED is inserted into its opening and then fixed in place with a small drop of glue. This ensures they stay perfectly aligned, while also preventing them from shifting once the device is fully assembled. With all the external components installed, the next step is inserting the main electronic board. The PCB slides into the housing and connects to the LED, the buzzer and the switch. At this point, it's important to make sure that none of the wires are under tension, that everything fits neatly inside the body. It's a little bit of a controlled chaos. A clean internal layout not only makes the assembly easier, but also helps prevent problems later on. And it's not a clean setup, by the way, a clean layout. Normally, I create some holders in a device like that to hold the PCB in place. Once the electronics are in place, the rest of the detonator housing can finally be closed and assembled. The remaining parts are aligned, secured, bring the entry prop together as one complete unit. With the detonator fully assembled, the next step is weathering and wear effects. Right now the paint still's just too clean. Most equipment in the Star Wars universe has clearly seen a lot of use. Ages of use. Years. Tens of years. Hundreds of years of use. So the goal here is to add subtle signs of wear, scratches and exposed metal. To achieve this, I apply small amounts of metallic paint to the edges and raised areas of the prop. These are the spots where paint would naturally wear off, first through handling and regular use. Okay, you use a detonator one time, but it's, you take it around and show it to your friends. And by lightly brushing the paint on these areas, the underlying gunmetal layer becomes visible a little bit again, creating the illusion of raw metal, using washes and so on. And yeah, it's important to keep the effect slightly irregular and natural, a little bit chaotic, because perfectly symmetrical wear looks artificial. With the weathering complete, the detonator finally looks, or starts to look less like a fresh painted model and more like a used piece of equipment. Now everything is ready for the final activation test, where we'll power it up one last time and see the full sequence in action. And that's it for this build. If you enjoyed the project and want to see more electronic ops build and maker project, just subscribe to the channel, leave a like or comment. Everything is welcome. And if you like to build one yourself, you can find the code and the parts list on my Patreon page in the next days, I hope. And all I can say is thanks for watching, and I'll see you in the next project. And have a really nice and beautiful day.